Hello, everybody. I hope you're having a good day. I learned I'm talking here just on Tuesday. I'm a substitution for someone who couldn't make it, unfortunately, but good for me, maybe good for you. And today I'm going to talk about a small application I wrote together with a data scientist and what we've learned on the way to make this application happen. So a little bit about me. I am a freelance consultant. I work with the public cloud. I write Python. Now I also write Rust. I organize Python meetups under the community by Amsterdam. You can get there via the domain py.amsterdam. And let's start. So first, at the beginning, there is a software engineer and there is a data scientist. They both work at the same company. It's a small company, and they both do jobs of 5 people at the same time, as usually. And you can see the software engineer works with the application code, delivers web applications mainly, and focuses on the code qualities and maintainability and the designs. On the other hand, you have a data scientist who often work just with the data. They write plain SQL. They use code. They use usually a lot of code, but it's mainly one-off jobs to produce this report or make a debt chart for a CDO or CEO, whoever has business questions. So they also explore data in Jupyter Notebooks mainly, or other solutions. And I wonder how many of you are data scientists more or software engineers. So either you can raise your hands or you can go to Slido and vote there.
Is there a third option? Shall I have to go?
You can raise both hands. Yeah, I deliberately disabled both options because I wanted to see if someone identifies as one or the other. Or both. All right. So yeah, as you can see, it's almost 50-50 here. And what I've learned from organizing meetups in Amsterdam is that many data scientists know how to write the code, but not necessarily have experience with the production grade code, which you usually need in a long term. So you need some monitoring and alerting and deployments and CI/CD pipelines. And if you talk this language to data scientists, they're like, what? So as I said, they mainly work in the Jupyter Notebooks. Is there anyone who is not familiar with the Jupyter Notebooks? Okay, I will explain it very briefly. So Jupyter Notebook is an application where you can write Python code or even other languages. And you get this cell where you write your piece of code, then you execute just one cell, and the whole application share the state in a memory. So basically everything you write in a cells is global. But you can also create functions, but not only functions, you can also write Markdown, or you can directly see the results in graphs. So there's an example with a matplotlib. That's why scientists love it, because you can work with data, but you can also see the data. at the same time. So, and this data scientist had a solution of, or had a need to run Jupyter Notebooks automatically on schedule to process some data and create some reports. So the data scientists went and did their best to write some sort of an application which can do the job. So there was a cron job which ran the application. There was something which created a virtual environment, but then there was a problem and I was asked to help as a software engineer. So then I started to look into the whole solution, and I found out there are a lot of problems from like a developer excellence perspective. So the deployment of the code, there was basically no deployment or no automatic deployment. So the deployment was run something on your local git commit, go to the server, SSH, and git pull, and then run something else. I was interesting, and then I found out that there is a Fabric, it's an automation library which allows you to run Python snippets across the network via SSH, for example. Is really nice, but I would not advise to use sudo commands with the Fabric library because it's not very safe. And these are some things I found in the solution. The code was quite okay, but it didn't follow any standards, it didn't follow any PEP 8s, or there was no formatting. So, but there are some really nice ideas. One of them was to use the configuration files, but they were partially hard-coded, so they contained also secrets. But the good thing was that the data scientist was aware that to separate the secrets from the actual code, at least somehow. So this is very important when you're working with other people. You ask them about their background and where they're coming from. So before you start criticizing the solution, you need to be sure that the other person knows how to take in your feedback, because I'm from Czech Republic and we are usually very direct, and if we say something, we usually do not mean it, but to the other cultures this may sound very harsh. And thanks for me traveling and being a consultant, I've learned rather quickly that it is very important to respect the other cultures and always try to ask upfront what the other person is familiar with, where they are coming from, so you can get a little bit of understanding of their background, so then you can comment on their whole solution. Because if we just look at this solution, I would say, oh yeah, this is wrong, this is very wrong, like we have to start all over. And then the data scientists will be upset because they worked really hard to learn all this. So instead of that, I went deep into the solution and tried to think not of the form, but about the ideas. What are there? So there were really good ideas of using config files, using a paper mill, and I started with that, and I highlighted, yeah, these are really good ideas. So I asked, how come the code ended up like this? And then you learn, okay, so there is no time, there is not enough skills because there is no time, so you cannot study when you cannot produce, so you have to kind of balance. So as long as the application worked, everything was fine because the data scientist was the only owner of the application, and everything was fine until they needed help or it needed to be bigger. So I decided to take a data scientist on a journey how to develop a software. So we started with writing down requirements. So we started with the production requirements. That we need to do something about deployment. It should be testable. There should be some linting on the code. The Jupyter Notebooks have to be automatically executed as they were before, but better or easier. There should be some configuration. There needs to be a logging. There needs to be monitoring and alerting in case the notebook or a job doesn't do what it's supposed to do. And then all this is quite a lot because it contains a lot of small projects or solutions. And where are we? Here, yeah. So you can see it's the Docker, Sentry, GitHub, GCP, and all that. That's usually very far from data science world because it's everything but data. So the goal was to enable data scientists to do their work while teaching them something about software development. So the next time they are in the same position, they can do better. And it is way easier for them to speak to the software people or DevOps about what they need. So after we declared production requirements, I wanted to do something about user experience or a developer experience. So decided that we will rewrite the cron jobs into a CLI application. We will package it with a Docker, and then it will allow us to run containers anywhere, almost anywhere. And there should be some checking on the parameters of the input of the settings. Then for the developer experience, we wanted to definitely improve deployment because nobody wants to go 2 times to the server to pull the latest change. We needed to improve on setup of a development environment overall because the whole project was scattered into multiple repositories, and the repositories shared the code, but they did not share the code via library. They shared the code via copy-paste. So you can imagine after some time, when you work on one project, it will divert from the other project. And while they are similar, they are also different, and that's the hell to maintain. And we also wanted to improve the ability to investigate when there is something wrong. Because at the beginning there was practically no monitoring, and the only point you've learned that something is wrong is when data were wrong, which is quite late. So we wanted to add for sure a deployment pipeline, make something about isolated environments, and improve on monitoring and alerting. In our company, we already have Sentry and a Datadog heavily used in all applications, so why not use it for data application as well? And that's how it became a Bookrunner. It's a very simple application. It's basically like a Lego. I picked pieces from Python ecosystem, some battle-tested libraries, and I will show, and then just put them together. Took me a week and a half, including the contribution to one of the libraries I picked. And it produced a very nice application that can run the notebooks, can do logging, and all that nice things that DevOps like. So we will go through all the bits and pieces, and I will talk a little bit about each. So poetry. How many people are familiar with poetry? Cool. So if you are not using poetry, what are you using? Pip? Conda? I tried with Conda, but locking files with Conda was not fun, and it was difficult to be fair. So what is poetry? Poetry is a Python package manager. In poetry, you define your dependencies in a PyProject toml file. And then once you have that, you run poetry install. That will create a virtual environment for you. It will also produce a log file, poetry.log, that will store a snapshot of metadata about the packages you installed. So the next time you're installing from the log file, you are sure that you will install exactly the same packages. There are some hashes and all that. All that was in poetry before pip supported it. Nowadays, pip supports it as well, but I still prefer poetry because the experience for the developer is much nicer. Yeah, it does dependency resolution and it does dependency groups. So the dependency groups, you can imagine you have different requirements for your local machine than for your production environment. So let's say locally you want to run tests, so you install a PyTest, but you don't need tests in a production environment because it will just increase the size of the package you are shipping. So with the dependency group, you can separate it to developers and the production and way more. The next piece of the puzzle is Click. How many people have built something with Click? Okay, nice. So Click is a battle-tested CLI library for Python. It's one of the oldest one, apart from ArcParse. ArcParse is great for a super small application, but once you need some subcommands and parameters and so on, it will get complicated from the software architecture point of view because you will have to write much more code and manage it compared to Click. So with Click, you can have optional arguments. You can have automatic help generation from docstrings. You can have required arguments. Click can also do some type checking on the input. So let's say you are expecting a number and the user writes a string. The Click will say, no, I want number. So that is very nice for writing a small command line applications or even large command line applications. The next piece is the typed settings. A reason I picked type settings is because they play very well with a click. So what it is? Typed settings is a project that helps you use settings files for your code. So you can use JSON, TOML, even PY files as your settings. And then you can load the settings via typed settings into a class, which is based on the address class. So you have very little of a boilerplate in your application code. You just see what you need to see or what you want to see. And is there anyone familiar with address? Okay, 2. So for those who are not familiar with address, are you familiar with the data classes? Okay, I see more people nodding. So you can think of address as the ancestor of data classes because the author of address heavily contributed to data classes. So address is like a data classes, but more. And that's what type settings is built on top of on. And there is integration with click. So I will show you it in the demo how this plays together. Then for logging, I decided to use struct log. Okay. I thought I have more. 25?
25.
Yeah. Yeah, so I'm almost there. So I picked struct log because it can deliver 2 things. Very nice developer experience, that you can see colors and all that on your local, but also structured logging for your logging aggregators like Datadog, because they usually prefer to work with JSON, but it's not very readable for JSON. And the star of the show is a Papermill. Papermill is a library that allows you to execute Jupyter Notebooks and parameterize Jupyter Notebooks. It also comes as a CLI, but I prefer to use it as a library because you can integrate it in whatever you want. And basically what you do, you point Papermill to a Jupyter Notebook. You say, this is my notebook. These are the parameters. And Papermill will make sure to run it and then output the notebook into multiple places you want. So for example, in this example, you can see we are outputting the notebook to S3 bucket. So, and the output is produced even when there is an error. So how the Bookrunner looks, you have a CLI, which can execute the notebooks, and you have the project structure. So let's try the demo and see. Oh, come on. There we go. Nope. I want you alone. Oh, come on. No, just ignore it. It's fine. Here we go. So we created a small structure with the projects. So every Jupyter Notebook project can have their own directory. Inside the directory, you can see settings file and a notebook file. Settings file is a plain TOML file where you can change any settings you define. Then in the notebook, you define your parameters, the way that you add a tag, not a comment, but you need to add a tag to the cell called parameters, and then the Jupyter, then the paper mill will replace the parameters with the actual one you supply via calling it. There is one problem with this. If you pass secrets, it will also store the cell in the output. So in case you pass secrets into your notebook as a parameter, it will store the secret in the output. So you don't want that. You want to load the secrets different way. But for our use case, this small application was super fine, and we could live with this limitation. So let's look at the code. Yeah. So here you can see I defined few classes as typed settings, and they are already CLI parameters and commands as well. So I didn't need to do almost any work to make a CLI happen. So here you can see I'm calling my class to produce a command, and that's all the code there is. Like it's very simple. It's just calling few files, and you get so much.
Okay, so the executor is paper mill?
Yes, the executor is a paper mill, and you execute it via the command line. Let's see. Yeah, as you can see, this is one of the examples of error in the notebook. And once you get that, you can go in the output and then examine the output, and you see the paper mill will tell you where the notebook failed. So with all the automation, come on, listen, yes. I built infrastructure around it, so it runs in Google Cloud Run, then reports to Datadog, and Datadog then reports to Slack. And then in Slack, if something goes wrong, you can see something like this, which is very handy. If you do not have many applications, if you have many applications, I would advise against using Slack, because then you get tons of notifications. And yeah, that's everything. It's time for lunch or questions.
Yes, thank you. Other questions from the audience? I think you were first. Yeah.
You mentioned that the paper mill putting security, it makes it security sensitive, not ideal, and you would go on this other way. Like, what direction are you in general thinking when you think I can put some mill at?
Could you repeat his question?
Yeah, so the question was what to do about the secrets in Jupyter Notebook, and what are the options. So a simplest way is to write a function in your Jupyter Notebook that will read environment variables. That way you can have your DevOps guy to inject secrets into your runtime. Or you can take the paper mill notebook and clean the cells with the secrets. Let's see. So this is the parameter that paper mill overridden. You can see here are the parameters I provided as a default, and these are overridden parameters. So you can take the output from the paper mill and erase this cell and then let it upload. But you cannot use Papermill that easy for this because that's not built in Papermill, so you need to go deeper in the code and take parts of their solution and build it yourself. So there is also a question. How do you teach data scientists to use version control or even data version control? And do you have a good way to version control Jupyter Notebooks? No, I do not have a good way to version control Jupyter Notebooks. We have a GitHub. That's the best we get. But version controlling Jupyter Notebooks is quite complicated because you don't really get anything from a Git diff apart from a large JSON, which no one understands until you work with the low-level Jupyter Notebooks. But how do I teach data scientists version control? There are some websites how to teach that teach Git. I can share them later. If you are interested, you can come to me. I will find them. I do not remember them from the top of my head, but that's how I learned version control from at the beginning. You get tree, and then you type commands, and the application basically helps you to work through all the necessary Git commands. And then once you are more comfortable, you will be, or your student will be able to ask more complicated questions about Git because they first need to learn concepts.
Yeah, makes sense. Well, yeah, I think there are more questions, but it's also time. So I want to wrap this up. So thank you, Jan, and you can ask questions in between talks. Yeah.